started.
Bing. Oh, I heard a bing. Hello, everyone. This is the Virtual Berlin Droid June 2020 meetup. And today we have a special edition. The Android 11 will be shown off today. So if you count the hearts, it's 11 hearts we have on the Android, but this is not all what we are offering today. We will also have 3 beautiful talks. We have one from Chad Haas about what's new in Android. I'm not going to read the text because this is what Chad is for. And after his talk, we'll have a quick Q&A session. After this one, we will have Ben talking about what's new in Android development. And also here, he will tell us more about this. Also afterwards, there will be another quick or not so quick Q&A session, depending. And the last talk of today is how do you deal with privacy changes in Android 11 by Jacine. Also looking forward for this one, and especially afterwards, there's a Q&A session for you to find out whatever you want to know. The question is, how do you ask questions? We have this beautiful slido.com interface thing where you can just ask your questions, and then at some point I will run through them. So please take your phones out, take a look at the QR code throughout your phone or the Google Lens, or go to slido.com, meine Güte, and enter the number there to join the chat. Also, if you have questions during the talk and don't want to go to slido.com, just put them into the chat and we will read them somehow. I will also post this link afterwards in a bit, but for now, just one more break into giving you the chance of scanning the QR code. And now the chance is over. But there's even more than this awesome event we have today in this little pages. We have our virtual Android co-learning every week. So on our Slack channel, which also another beautiful QR code you can scan and join our Slack, we will be talking, we will be writing, we will be even listening and together explore what are Android apps. So this means you come with a project, you take a look at it. If you have questions, ask them. And what we did over the last 2 weeks, we were actually looking at the Corona app. So they are open sourced for the German government. And we were just looking through the source code, building some things and seeing how this works in the background. So if you want to hang out with the Android community every week, join our co-learning channel on Slack, and we will post a link for the virtual meetup there every Thursday around 8 o'clock Central European summertime. That said, if you also want to give a talk at one of our meetups, may it be virtual or in one of our meetup spaces, please take a look at our talk.berlindroid.de page or scan this other, I think it's the 3rd or 4th QR code today, to go to the site and just let us know what you want to talk about. And then we evaluate it with the other talks we have and come back to you with an idea when you can give the talk. Again, this is the awkward waiting time for somebody to maybe take a picture of it, maybe even a screenshot, like I just did. And with this one, I go over to what is happening in the next month. We don't know yet, but we can talk about it at July 29th and just see what other talks we will have then. Again, it's always the last Wednesday of the month. In this case, it's the July 29th. Feel free to join us here. And with that, I don't have any more slides to go through. So now it's your time to shine. Chad.
Let me present my slide. All right. I hope that looks okay for everybody.
Great.
All right, excellent. Let's go. A lot of content to cover, not a lot of time, but you know what? I've been practicing talking really, really quickly ever since I've been practicing talking. Thanks for hosting the event. Thanks for having us. Let's learn about some Android stuff. I should point out that the stuff that I'm going to talk about is essentially covered in one of the launch videos called, bizarrely, What's New in Android. So if you prefer, you could go to the launch site and check out the video and play it at 2x and still come back in time to see me wrap up. Otherwise, let's go into the stuff that I have. All right, so what is new? Well, normally I give this talk with a couple of co-speakers, so that's new. But otherwise, the talk is essentially the same kind of talk that we give annually ever since I was new on the team. 2011 was when we started talking about this. We talk about what is new in the release. We also talk about what is new a little bit in the tools, although there are deep dive sessions for the tools you can go learn more in. And we also increasingly talk about stuff that's going on in the libraries. I'm going to briefly mention some of that stuff. Again, there are deep dives like what's new in Jetpack and the launch videos that you should check out for more of the details there. But let's get going. First of all, my favorite area, the user interface area. So there were a couple of interesting changes here. One was window insets. We were overdue for a change here. This is a very old API that has offered the same functionality for a long time in many releases, and now it offers both less and more. We offered information about what the constraints of the rectangles were on the screen that you needed to know about, but we didn't actually tell you why. We didn't tell you the windows and why this information was changing or why it was being set the way that it was. Instead, we just sort of gave you the geometry of the situation. Now we actually give you that information. We say, this is the information for the status window, for the IME, for the stuff that you actually care about. So the way that you use it is essentially you set up a listener, and inside the listener, you can get the insets and you can ask for interesting information like, this one's a shocker, is the keyboard visible? Or you can also, importantly, get information on how is the keyboard visible? Where are those insets? What's the information that I need to react to? So the question is, why did we make these changes now? Well, we were overdue for making them. So we added the type information. Also, by the way, we deprecated a bunch of the stuff that we don't really want you using anymore because it doesn't have the right information in it. But more importantly, we introduced my favorite feature, which is IME animations, and we really needed it there. This is about synchronizing content on the screen with the keyboard itself. So before, the keyboard would nicely, smoothly animate in, and your application would get information later that the screen had changed and it would snap into place. And there was really nothing that you could do about it. Now you can get the information not only that the keyboard is coming in, but also frame by frame information on where the thing is, so you can actually react to it accordingly. And even more powerfully, you can actually drive that animation directly. So let's see how that works. So here's a screenshot. This is from a sample that Chris Baines posted. On the left, you can see the default interaction of the keyboard where it snaps into place. It has this animation up there, but you can see the application actually moving with the keyboard. That's because it's listening to the animation changes frame by frame and then adjusting its content appropriately. On the right-hand side, even more interesting, as the user scrolls the content up, it actually drags the keyboard up. And this is done by essentially driving a frame by frame animation directly. So as the content of the application changes, then we actually tell the keyboard where to be on the screen. So in code, it looks a little bit like this. So the one on the left where the keyboard just automatically animates in, we can listen for these changes and then react accordingly for the content in our application. For the one on the right where we're actually driving that animation, you may just drive it as an animation, a set and forget animation. We're doing something more interesting with the gesture where we're actually pulling it frame by frame. So here we're saying we're going to have an animation of infinite duration because it's going to go until the user is done dragging it back and forth, which according to the animation will be never. According to the screenshot at least. Linear interpolator, we don't want it doing motion interpolation. We just want it to move exactly where we're telling it to be. Because that is the gesture-driven part. We can handle cancellation. We can also listen in for life cycle changes on the animation. So very powerful way to interact with this thing. You have been asking us, the developers have been asking us for this for years. Turns out it was really tricky. We tried to do it in Android 10 and didn't quite make it there. So now it's there in Android 11. So check out the sample for that at the following URL. Go see how it actually works in the code. Conversations is part of an overall big change in the UI for Android 11 around people. So clearly everybody uses their phones for many, many things, but one of the things we do most is interact with other people, whether it's colleagues or family or friends, and the ability to return to the conversations that we're having very easily is kind of key. So if you are in a chat and then you go and you're in email or browsing or whatever, and then you want to go back to that, wouldn't it be nice if you didn't have to go back to the home screen, launch the application, then sort of go click, click, click until you finally get back to where you wanted to be before. So now we have the ability to take that people-based conversation from these messaging applications and propagate it into notifications that A, are more visible in the UI, so you can see what's going on much more easily, and B, can take you more directly back to the conversations that you want to be in. So here's an example here where you have this conversation set-aside area at the top of the notification panel. And you can long press on any of these and change some information about it, like how you want to be notified about these things, as well as what the priority is. Actually, this conversation with the school district is way more important to me than the other conversation, so I want to set it to be top priority, which will boost it to be at the top of the list of the conversations. So the way it works in code is you create some information about person. Person is not a new API. I think it was in Android 10. But now we are integrating that in with shortcut information, notification information, sort of bundle all of this stuff into the conversations experience. You create a long-lived shortcut. Needs to be long-lived. And then you push that shortcut. You need to use messaging style for this all to work. And then you build your shortcut with the shortcut info ID that we have above. And then the magic happens. So conversations is about putting stuff into the notifications, but that actually integrates well with another feature that is almost new in Android 11. Bubbles actually came out in Android 10, but it was a developer option. It didn't quite make it to the finish line in terms of the fit and finish that we wanted for the API and the functionality. So we put it in as developer option so developers could start playing with it, but couldn't really use it because users wouldn't know how to enable it. So now it is there for real. It's a feature. It is opt-in for users. So if you have this in your application, then the first time you post a bubble, the user gets to say whether they want that floating on their UI. But if they do, it's going to look something like this. So this is from a sample that we have. You have a bubble up there on the left. If you tap on the bubble, then it brings in the screen on the right. So the screen on the right is not getting back into your application. Instead, it's a mini activity that represents the conversation that you were having that you are now returning to. Let's see, talked about all of that. So one of the important things to note is really the only way that you could do stuff like this before was by using System Alert Window. System Alert Window is this incredibly heavy hammer for doing this. Like if you want a little notification on top of the UI, essentially you're posting a transparent window over everything that you're putting a little notification window, a little bubble into. Not really the kind of experience that we want for applications, developers, or users on the system. So we would recommend that people stop using System Alert Window for this very common usage pattern and instead use bubbles. It uses the notification API, which means that you're already doing most of the work that you need to actually create and use bubbles. All you need to do is populate it with more metadata and to create this mini activity that we saw before in the sample. So first of all, you say, I need an activity. You're going to create this mini activity, and it needs to be a resizable activity, because as we saw in the sample, in the screenshot, it was smaller than the screen, right? It was popping up in place in the UI, but it wasn't taking over the screen like normal activity windows do. Then we create the intent for that activity. We create the metadata that we need for the bubble. The shortcut info is probably something that you're already creating for the other conversations info, or just notifications or shortcuts in general that you're already dealing with. And then we create the notification with that metadata and the shortcut ID that we're setting. So you're doing most of this already. You just need the mini activity and you need the bubble metadata, and you're good to go. There's a talk on all of this and more, what's new in System UI, that was part of the launch videos. The sample that we had screenshots for earlier is posted in the Android samples on GitHub. And finally, we talked to the Bubbles team in episode 140 of ADB. So check out the podcast if you want to know more from Maddie and Archer. Privacy, I would like to talk about this, but I'm not sure that I'm allowed to. More importantly, Yassine is going to be coming on in a few minutes, and he's going to give you way more information here, and I would rather not duplicate that information. So let's just move on. Yes, so I think that's the name of his talk. Anyway, so developer goodies. One of the other things that we focused on in the release was making things easier for developers. I don't think that anybody says that Android development is easy, but I'm not sure that it can be, given the vast amount of stuff that you can do with this platform, from using the database to talking to the web and server and the backend and the UI and performance and constraints and like all the things you have to take into account. I don't know how to make that easy, frankly, but what we can do is make it easier, right? We can continue improving the tools and the processes and the APIs along the way. And Android 11 made some of those steps along the way. So Wi-Fi debugging is I think, a kind of a cool part of this, because who has enough USB ports? So this is a picture of my laptop about 3 weeks ago, the one that I'm actually using to broadcast this talk now. And it's actually gotten worse in the time since then. Now, instead of one dongle for USBs, I actually have 2 daisy chain dongles because, again, I needed another port. So you just get another dongle and plug it in, and you hope that nothing fries along the way. So Wi-Fi debugging now allows you to not use yet another USB port for talking to your device. It's a little bit manual right now. You need to enable it through the developer options, I believe. Also, there's command line settings to actually pair and connect with the device. The intent is to have it accessible in Android Studio, and I believe the Canary release of 4.2 has this capability. So if you want to use it, check out the Canary. Otherwise, it will be there in a stable version of Android Studio soon. We added a lot of annotations to the platform APIs in the last couple of releases. There are 2 kinds of annotations that we add to make it easier for Kotlin developers that are writing to the platform APIs. One is the recently set, recently not nullable or recently non-null. This basically says, yep, we've just added this annotation. This is the contract that you should obey. And if your code calls that API in a way that does not obey that contract, it will be a warning in your build. We will not break your build, but we will tell you that you are doing something bad and you should probably fix it. On the other hand, if we already had a recently annotation there, we may have upgraded it to full-on nullable or non-null. And now, again, in your Kotlin code, if you're calling it with the wrong contract, then we're just going to break your build, because, frankly, you should crash at build time instead of runtime. That is certainly the intent. I think it's what everybody would like, especially the user. One of the things that's most difficult about chasing bugs is being able to reproduce them, especially reproduce them in a real world situation. The setup that you have, like, you can't possibly have all of the possible devices that your users do, or all the different constraints, or all of the, the bandwidth constraints that they have, or the other apps, or whatever. Like, what is that situation the user ran into where they're hitting a crash that you have never seen before? Now you can get more information on those crashes in the field. So there's an API where you can query, why is it that my application crashed recently? And then you can upload those reports to your server and deal with them. So you call this API to get all the exit reasons, and you can walk through there and find out, did it crash from low memory? Was it just a flat out something crashed? Was it an ANR? So ANR turns out to be a little bit tricky to get information on, and Crashlytics or these sort of crash reporting services, like, they can kind of connect the dots and decide that it was an ANR, but they don't really have a lot of detailed information. Now the platform is propagating that information. So whether you call this API directly or whether it's taken on by the crash reporting services that maybe you use already, it should provide a better mechanism for you to get real in-field information about what's going on in your application. GWP ASAN is sort of a smaller and leaner version of something that we introduced in Android 10 called HW ASAN. It's basically an additional allocation service that layers on top of the memory allocation service for native applications, native code, that will catch errors, right? So instead of allocating that memory directly, it goes through this little indirect mechanism to flag what's going on with the heap. And then if you end up accessing that memory in the wrong way later, we know it because you are now going through this indirect mechanism where we're actually tracking all this stuff. This is great for development time, but it's not great for your users because it does bulk up the size of your APK with this extra scheme. It also introduces a little bit of overhead every time you allocate memory. So this is not something that's intended for the field, but GWP ASAN is. It does the same thing. It catches memory issues for these native apps, for this native code, but in a sampled way, just like not system trace. The trace profiler has a sampling mechanism where it's not doing tracing on every method, but it just samples occasionally. We're doing the same thing with memory. We set up to do this sort of indirect mechanism for some of the memory accesses. And that way, if you happen to call one of those accesses in a bad way, then we will catch that. It's a bit more random because it's sampled, but that means that you can actually ship this with your code into the field and actually catch real world problems. So there's lower overhead. I think the library is something along the lines of 60K. and also lower overhead at runtime because it's just not getting in the way of that many memory accesses overall. But scale that across all of your users in the world, and you're going to get a lot of information about what's going on there. And then also the reports are automatically uploaded to the Play dashboard. So what happens is you enable it here in your manifest, and then when you get one of these bad memory accesses, the app will automatically crash, which automatically triggers a crash report that gets uploaded to your Play dashboard. And you can check it out there. ADB incremental is for applications that are really, really huge and take a while to install on the devices. Think games. So if you have like a game that is 2 gigs, you have tons and tons of assets, and then you want to fix one line of code, then you need to wait for that entire APK to ship down to the device to see whether that was the right line of code. Wouldn't it be great if you didn't have to wait that long for such a small fix? So ADB incremental does that. You can get up to 10x speed up, even more if you just want to push like the salient code that matters instead of the entire application. So check that out. Here's how you do it. You need to sign in a slightly different way and then install -- incremental, and away you go. There were a lot of behavior changes in every release there are, especially in the privacy area. You'll hear about some of them from Yassine later. One of the things that we're doing in this release is trying to make those easier to absorb. We know that this is difficult when things change out from under you. So for the most part, the behavior changes in this release are limited to applications that target this API level. And we also made it easier to test these changes one by one. So you can toggle the behaviors on and off and see how they affect your application. You can do that on the command line, which you could do to a limited extent in earlier releases anyway. But we've also enabled a new UI in developer options that looks a lot like this. So you've just got these toggles for the various flags over there, and you can enable and disable them and test away. You can see on the left, if you want to use the command line approach instead, then you run a command like this, and that's going to disable that. I'll do that again so you can see that nice graphic on the right. I worked so hard on that. Graphics and media area. If you are an NDK developer, you were probably frustrated for years that you could not access all of the decoders that we had directly on the platform. So we have a bunch of native code in Skia that has all the decoding functionality, but then we have an Android SDK API in the Java API layer, and that's the only way to get to those decoders, right? So if you're writing an NDK application, you're in native code, and you're calling up through a JNI just to call back down to native code, which I think is just is frustrating, right? You know it's right there, but you just can't get in the door. So now we've enabled that. We have an NDK API for all of these. So you can access all of the decoders that you could have before through JNI. One thing, so people would do this JNI upcalling, or if they just didn't want to bother, they're a native developer, why are you making me do this thing? What they would typically do is just bundle an extra library, which means they're bulking up the APK size. So now you can avoid that and just call the decoders directly. Works something like this. You create the decoder from the asset that you want, and then you set up the bitmap to receive that information of the appropriate format, set up the buffer, and decode the image. And then it probably looks like a teapot, because all graphics do, right? So there's a sample that shows this, as well as other NDK development stuff you can check out in the Android samples on GitHub. HEIF is an image file format that offers size savings over similar image formats out there. And now it has animated capability, or rather, we have the ability to load animated HEIF files. So they come in just like animated GIF files as animated image drawables that you can then just play like an animation. But they are smaller, so worth checking out if size is a concern. So you do something like this. You've got a reference to a file. You create the decoder from that file, and then not on the main thread, please. Decode the drawable. That is going to take some time. And then if it has come in as an animated image drawable, that means that it does have more than one frame in that HEIF file, and it is that animated format. You can go ahead and start it. If you are an NDK developer and you're doing audio development, then maybe you are using OpenSLES. We are essentially deprecating that and saying that you should use Oboe instead. Oboe is an open source library for native developers. offering high performance audio as well as lower latency audio. Works all the way back to API level 16. It is on GitHub, and we talked to the engineering team. We talked to Phil and Don Turner on episode 135, so you can hear about how it works and how to use it. Variable refresh rate. So since the dawn of time, or at least the dawn of my time working on Android, devices have essentially all run at about 60 frames a second, which gives you about 16.67 milliseconds in order to do all of that work that you need to do to then render a frame, and hopefully you can do that on time. Now, if you have your an app with its own rendering loop, then you have the ability to sort of back off and not run at 60 frames if you can't. So if you can detect that you are not running fast enough to go to 60, then maybe you want to back off to a slower rate, so you can at least have a consistent frame rate instead of constantly sort of going between 60 and then missing a frame or whatever. But unfortunately, if you can't hit 60, you want to back off to the next available unit, it's going to be 30, right? Because that's how the math works, right? If you can't post it at 60, you're going to post it every other one, and all of a sudden you're at 30 frames a second. So now there's something going on with devices where they offer faster rendering rates and even sometimes flexible rendering rates, where they can go up to 90 hertz or maybe even 120 frames per second. And the advantage is, yep, it's smoother, it's faster, you know, especially if you can render at these higher rates, but also there are more flexible back off rates. So now if you want to back off, well, I can't hit 120 or I can't even hit 60, but maybe the rate that you can back off to is going to be higher than the default of 30 if all you had is a 60 frame rate. You're going to use one of a couple of different APIs like set frame rate, and this is essentially a hint to the system. So it's not saying you are going to get that frame rate, but you're saying, I would love to run at this frame rate if you can. And then the system takes that hint as well as hints that it may be receiving from other applications on the system. If it's showing several windows at the same time and they have conflicting requests, then it basically figures out the right thing to do for the best frame rate overall. There's a thermal API for NDK developers. This existed to some extent at the Java, at the Android SDK level already, where you can find out what is going on with temperature. Why do you care about temperature, you may ask? If you're not in the Antarctic, it actually matters anyway. If it is running too hot, that means that there is a problem and the system is going to start taking draconian measures to stop that problem. You do not want a device to overheat, so it will stop using the large cores. It will slow things down to slower frequencies. It may start, you know, killing off apps. I think it's mainly about sort of slowing everything down, but maybe you in your application know how to slow things down better. Maybe you can back off to algorithms that aren't taking as much CPU. You can back off to a different rendering rates, lower resolution assets, whatever it is. So now you can actually react to these thermal issues and make changes without the JNI upcalls that you used to have to make to call the Android SDK for that information. So it works something like this. You have a listener and it will call you when there has been a change in the system, and you can find out whether one of these important things is going down, like everything is too hot and I'm shutting things down immediately, or there's an emergency. Could be your app is not going to function very soon, so you probably want to do something about that. Or there's, you know, everything is fine, status none. I don't know why you want to know that. I would hope that would be mainly the case. So you register the listener, and then you listen away, and then you can unregister the listener later. Angle is API that we have for if you're writing OpenGL code, if you're using OpenGL, but you want to use the Vulkan renderer, the Vulkan driver, instead of the OpenGL driver, sort of test how it works on different devices, see if that offers a performance or functionality benefit. Then you can do that in developer options. You can enable Angle. It's not enabled by default, but you can see how it's working for you more for future benefit. There are other things going on in the platform. There's NN API, the Neural Network API version 1.3, functionality like conditions and loops, sort of, you know, standard software stuff. They are now integrating into this to make it a little bit easier to actually branch in your code. They're offering hard swish op, which I'm going to talk about just because I like the name a lot. It offers, I think it's a higher performance inference engine as well as higher as well as, better correctness. There's also improvements to avoid copies, like expensive copies of these buffers between CPU and TPU and GPU. So lots of improvements there. Check out NNAPI version 1.3. For 5G, if you're on a device and a carrier network that has increased capabilities for bandwidth and lower latency, then there are APIs that you can use to find this information out in case that can change the quality of your application. Maybe you want to stream at a higher resolution or offer higher resolution assets coming down the pipe. So you can see whether it has the capability, whether you're on a metered network, for example, or whether you're on one of these fast networks, and then you can change your application logic appropriately. We have new capabilities for biometrics. You can now specify the strength of authentication. So you get the manager, and then you can request a particular strength, and then you can ask whether the system can actually authenticate for that. And then you go through the process of authenticating it. If it cannot authenticate for that, then you can authenticate for some of the strength instead. Autofill and keyboard integration is interesting. We kind of have two suggestion APIs in Android, right? You have the normal keyboard, and it has suggestions in the suggestion bar above it. But then if there's an autofill capability in an application, then it's going to pop up its own UI, right? You're going to get a little drop down with choices to pick from there. But we wanted to merge those, so there's basically one suggestion UI for users to interact with. So this has implications for both sides of the equation, both the keyboards, if you're writing a keyboard app, as well as password apps, which is where the autofill functionality comes in. So the password app is responsible for populating the information about that content, and then the keyboard is responsible for showing that content. I should point out too that this is secure. It's not about actually passing the content back and forth, because that might be a problem. But instead, it's about passing UI that displays the content. So it looks something like this. So autofill, maybe you have an email address, and that can pop as a suggestion in the keyboard, or credit card, or address. In code on the keyboard side, you have this request that you fill out there, and then later a response, and this is where you get the information to actually populate the UI with. On the password side, you're going to listen in and get this on-fill request call, and in there, as normal, you set up a data set, but you're then going to create a fill response with that data set that gives the information that can then pass back to the keyboard to display it. We also have changes in outside the platform, unbundled libraries, and Jetpack. Jetpack, of course, is this huge suite of libraries. I was told this is out of date. We're now well over 80 libraries, but who's counting? So these come out like every 2 weeks. We have future versions of all these libraries in alpha, in beta, in RC, in stable, as well as there's even one that's like pre-alpha, which is what Compose is going through right now. So tons and tons of releases. Some of the recent things that you should check out are Hilt. So this is the recommended approach for doing dependency injection on Android. It is built on Dagger. Even though it shows up as an alpha library in Android X right now, it's actually based on a stable library from internal that ships with Dagger, which is why we're recommending it. So definitely check that out and give us feedback. Paging 3 is a complete rewrite in Kotlin using coroutines and flow, which is kind of nice because this library functionality is all about asynchronous behavior as it is streaming data into the recycler view. So it makes it a lot more elegant and easy to get that information, put it in your UI. App startup is about making your app, helping your application start a lot faster. One of the bottlenecks for many applications is they use many content providers, and one by one they start them up, and each content provider takes a significant chunk of time to start up. So app startup, among other things, will pool these things into one single content provider, making it easier for your application to avoid all of that overhead. Also, Camera X recently went beta, so you can check that out as it approaches stable. Camera X is all about making it easier to write camera applications that can scale to not only all these versions back to Lollipop, but also this massive device ecosystem. So all these devices that sort of interpret the camera APIs a little bit differently, and Camera X smooths the rough edges there and has the workarounds inside the library that you would typically need inside your code to handle things correctly. Jetpack Compose is the new UI toolkit for Android that is not quite done yet, but is worth checking out. It's a reactive programming model. It's written completely in Kotlin, coroutines, all these capabilities that we're all going to know and love. It is pre-alpha right now. I think developer release, I don't know, 8 or 9 came out recently. Check out the Jet News sample and the tutorial on the website if you want to learn more. And there's one of the launch videos goes into detail on Jetpack Compose. Android Studio has 3 releases out there to care about right now. Motion Editor just went stable in 4.0. Motion Layout was always written with a tool in mind, and this is the tool. It makes it a lot easier to create these rich animations. Layout Inspector was substantially rewritten with a lot of capabilities, like finding out where was this resource thing defined? How do I get to that code? And why is my text blue instead of black the way I told it to be? 4.1 beta, database inspector, so you can see live what's going on in your database. If you're using SQLite or room wrapping SQLite, you can use the tool and the device, sort of go back and forth and see the changes live. And the 4.2 release is currently in Canary. This is where the wireless debugging capability is exposed right now. And also, if you do want to play around with Jetpack Compose, because it is pre-alpha, it is only exposed in the Canary releases. So check out the Android Studio Canary to do that. There's various things released for games, the game SDK, including utilities like frame pacing and the performance tuner. There's profilers in Android Studio, of course, and there's also beta capabilities that you can register for, like a plugin for Visual Studio for doing game development there, if that's your development flow, as well as the GPU inspector, which is kind of crucial for graphics, low-level native graphics stuff. Google Play has a new Play console. Basically rewrote the entire thing, make it a lot easier to use. You can find out what's going on with acquiring users out there, managing the team that's using the dashboard. It is currently in beta, and you can register there. And all of the videos, some of which I've mentioned here, are available on the launch site. 11 weeks of Android is ongoing right now. Last week we had people. This week is machine learning. Next week is privacy, and on and on. Lots of new content being posted, videos and articles and code labs and screencasts and podcasts and all sorts of things every week. Android 11 meetups, just like this one. Enough said. And finally, now in Android, I find it confusing to know all of the things that the team is doing, because think of our team as being many, many smaller teams pushing independently. So every couple of weeks, I try to collect that information together and write an article with the highlights from the last couple of weeks, and then record it as a video and a podcast as well. So you can check that out. And that is it. Thank you.
Wow, thank you for this run through. This was amazing.
Don't know if I was on time. I have a feeling I was late.
You were perfectly on time. It was great. So it's like everything is planned out and very, very well organized here. It's fine. You did the right time. So now take a bit of a breath, drink something while I'm taking a look at the questions we have already. Oh, and we have quite a bunch of questions. Feel free to take a look at the link Katik posted before if you have questions yourself. Otherwise, I just posted it again, and we'll just go through some of the questions starting from the top, I think. No, from the bottom, because this was the first one. How do you mispronounce Hive properly?
I was told it's Heath, but if you want to say GIF, that's fine.
And next one is, why is the database inspector so slow, and why is it not giving any UI feedbacks when it's doing whatever it's doing to load the database? Don't hit the messenger. If somebody knows who asked this question, and if you are even in the chat yourself, maybe you can come up and that's also a great option.
Put a message. Really, whenever you have any issue with Android Studio, the only way for us to be able to make it better is to file a bug tracker. It may sound that we don't check them, but we actually check them heavily. And more information we have, better we will be able to nail down a problem issue. If you have any problem otherwise, making sure to fill properly an issue, you can just pick Android Studio on Twitter. I'm the person who monitors that Twitter account, so I'm constantly checking all the mentions there. I'm not always perfect, but please file bug reports. It really helps us a lot.
Nice, thanks. Again, pronouncing things, right? So one of the questions is, will the new Bluetooth Gable Dorsch E stack become the default one in the field of in the final Android 11? Will it be updated from the Play Store? I hope this means anything to anyone.
I have no answer for that. I am not familiar with that stack. I also don't know plans on updatability. In general, we don't talk about future developments. On this one, I can honestly say I just don't know. Anybody else from Android? I'm seeing shrugs.
I can tell you a couple of things about Gabeldorsch, which is a fish, but not about the Bluetooth stack here.
Then let's just continue with the next ones, right? I mean, we are in a flow right now. Is there a backwards compatible way to access the NDK image decoders?
I doubt it. I mean, the thing about platform releases is this is the API. It is part of the platform and the release. There's no way for us to push that backwards. I just don't see how they would do that, especially, I mean, there was no public API before, so how do we expose that in a way that's going to be safe? Don't think so.
Yeah. Cool. I don't know if you are commenting on competitors' events. So, like, do you have any comments about the WWDC contents, for example, through the iOS Honeycomb?
I am overjoyed to not comment on other companies' doings. We're here to talk about Android.
That's what I thought. Can we expect more Android X libraries to be written in Kotlin? I think the answer is yes, but sorry, Florina.
I was hoping Florina would jump in.
Yes, stay tuned. Follow now in Android to find out whenever a new library is released.
Nice. Is there a way for us developers to propose old Android APIs to be marked as deprecated?
Generally, again, the issue tracker is the main thing that you can go for. Also, if you feel there is a specific API that should be deprecated, you can let us know either here in the chat or like afterwards on Twitter. We're looking at these things as well. But like Asidin said earlier, the issue tracker is one of the main things that we're looking at for a lot of the input that we're getting from the developer community.
Mm-hmm. Cool. And then I have one more, which is with a Kotlin state flow coming soon, will live data be deprecated?
I can talk about it. Not anytime soon. So there are a couple of situations where live data fits perfectly in the app architecture. And right now, Stateflow is in experimental, but also has some limitations that live data doesn't. So we have to talk and to work with JetBrains to see how we can improve Stateflow. Because, for example, one of the main issues is that you cannot have a null value inside Stateflow. That means that now you have to change your architecture to sort of allow an empty state or something like that. So we are working closely with them. Follow now in Android.
It's always a good call to action, right? I just found that I can scroll down in my list, and there were 3 more questions popping up. So hooray. If I activate Bubbles in Android 10, will I see Bubbles implemented targeting Android 11 on my Android 10 device? Dirk, do you feel like, I don't know, does somebody except for me understand it? Or otherwise, Dirk, feel also free to speak about it.
Well, Chat said it was possible to activate Bubbles in the developer options on Android 10. So I was wondering whether I have an Android 10 device and I activate it there, and then developers implement these bubbles. Will I see them on Android 10? Or was there some incompatible change?
Yeah, that's the key. Is are there compatibility changes? I know they tweaked the API to some degree. I know there was changes like it used to require 3 different manifest attributes instead of just the resizable. So there were some different requirements. I don't know if there's incompatible API changes. I think most of the functionality should be the same. So if you just want to test it there, if you don't have Android 11 yet, I would assume you could do most of the work with the earlier version, then make sure that you port it. But yeah, I don't know if it would work out of the box automatically.
Okay, thanks.
Thanks.
And then I have one about the Compose library. Will it replace the current development way in the long future? Will we soon all be developing with Compose?
I guess that's the goal long term. We can't tell you right now what long means. If long means a few months or a few years, but yes, that's the goal. That's why we are building it.
I think we can definitely say that long is greater than short.
Thanks.
I'll commit to that here. You can quote me. Actually quote Florina just in case.
Okay, unless I'm doing the technology part of the technology wrong, I think those are the questions we had in our Slido. I think we can take another 3 to 4 minutes if there are questions coming through the chat or somewhere here. Just reach out and see what's happening.
There is one about, so I will just read quickly the question. How would you explain the difference between data access auditing? This is one-time permission access. I will just say, wait for my talk.
Nice. Also a nice tease.
I think we should go forward because we have 2 more talks. We shouldn't wait too long.
Okay. I just wanted to let people breathe, but we can also just let Ben keep taking over the screen.
All right.
And by the way, no one stops you to ask you later as well the question.
So building on top of what Chad said on what's new in Android, we also have a couple of things to talk about with modern Android development. So yeah, modern Android development. Before we talk about that, first, let's take a short step back and talk a little bit about classic Android development. So we talked about modern Android development since, I guess, roughly 2018 is when we started using the term that was coined by Chat and Roman, if I'm not mistaken, at a conference in France. And from there, that was taken on, and we considered to find ways that we want to talk about this. And also, one of the things that we now do is, well, we now talk about it as compared to classic Android development, or like, well, pre-modern Android development or something like that. So previously in Android development, we had language as the main language. We had the Java programming language with benefits like a large developer base and existing and free to use tools for developers. Libraries, patterns, best practices, and all that is really awesome about it. And it's a robust robust language with automatic memory management, comparing it to C++, for example. With tools, we had Eclipse and DADT that I know several of the developers were big fans of. It was also a big plus point is it was free, and developers were already familiar with it. Myself, at university, I used Eclipse quite extensively, so I was very happy that it was free back then already. And there's also a good thing about it, which is we could easily integrate tools into the IDE, and other folks could integrate subtools into the IDE as well. And yeah, it was free. It was really good for developers to use because people could just start developing with Eclipse on Android very, very, very easily and very, well, cheaply. For the APIs, let's take a look at that. We had the platform, which we had frequent new releases. In the beginning, really very frequent new releases, if you remember that, but I'll give you a brief overview on this in a second. We also had new functionality in new release, which also means that we had new bug fixes in new releases, and bugs that were introduced, well, had to wait for a new release to come in to be fixed. So taking a little bit of a look at the timeline, we had 1.0 at late 2008, and then coming up with then 1.1, 1.5, 1.6 within a year, even 2.0 within the same year, and then like slowing down a little bit by half a year, roughly a half-year cadence, and slowing down to about annual cadence, which now is the cadence that we have with Android releases, which makes it a lot more manageable for developers to catch up with this. Let's take a look at the distribution. How did you distribute the application that you created? Well, technically, still the same gets installed on a device. We look at APKs, which were zipped files, which then get unpacked on device, and the device can use it. You had some more configuration options with config APKs and flavors and all this, which, well, flavors you still have, but that would also mean more APKs. Or, well, on the other hand, you could configure differently with bigger APKs, which leads to its own set of problems. Speaking of problems, classic development has classic problems. So let's take a look at the language. With the Java programming language, it's still a great language, but it's verbose. For tools, we can take a look at Eclipse and ADT again, which we had back then. It was difficult to make customizations there. The UIs were very inconsistent, and once we made an update there, it was really hard to make updates across the board. And they were also stuck within the ADT rather than throughout the entire IDE. And the core IDE wasn't actively being improved in a way that we were able to, that we wanted it to be working with it. So we had no real control over that either. Let's take a look at the APIs in general. For the platform, developers had the very limited users in the first place, because a new platform comes out and it takes a while for developers to catch up for this. So that all the features that you want to use as a developer, well, you're going to be looking at a couple of years down the line until a major share of your users are actually using that part. I know it's difficult to adopt new technologies and fixing stuff retroactively because, well, it's just forward-looking. Anything that is baked in is backwards compatible. And that means we had no way to just remove stuff in the first place. And not just because of you as developers, but also because, well, users, they're still on these releases. We have to support that as well. And that means if you want to add a new release, then that should be backwards compatible as well. And yeah, it's also complicated. Take a look at lifecycle or storing data on your device or just navigating an app from like one screen to the other. All of that was a bit complicated. And if we're taking a look at all the things that were previous and a bit difficult there, let's take a look at how APKs were distributed. We had monolithic APKs, which were able to handle all possibilities of your user's device. So essentially, you ship all resources and all the code to user's device, even though they might not be running it at all. Because, for example, if they have a CPU architecture, that's not going to change from devices have a set CPU architecture that doesn't change. Also, the resolution of a device rarely changes over time. Or on the other hand, you would have a very tricky process in order to create your own APKs with version code offsets that you had to adhere to in order to make sure that everybody gets the right version for the device. And it worked, but it was a lot of that was offloaded to the developers. So our answer is modern Android development. We're trying to address all these problems with that paradigm that we have here. And it is based on a couple of pillars around tools, APIs, language, and distributions. And we are recommending it. That means that we have our opinions, and we are being opinionated about this. That's a thing that developers have asked us a long time. And this way we want to help you to create better apps that run across several billions of devices. So what we can see is basically kind of like a house with a couple of pillars. So on the roof of modern Android development, we have language, tools, APIs, distributions, which stands on the foundation of the platform and play. So with that out of the way, let's take a short look in the language. The modern language is Kotlin as our recommended language for Android development. We've been going Kotlin first as well. But before I just talk over that slide, let's take a look at the timeline. In 2016, Kotlin 1.0 was announced. In 2017 at Google I/O, we announced Kotlin as the officially supported language for Android as the third language coming from Java programming language and C++ for native development. And at Google I/O 2019, we said we're going Android, we're going Kotlin first. We're heavily investing in the language. And just recently, we said that we're using coroutines as the preferred way to do asynchronous operations on Android with Kotlin. which is where we currently are. There's still like stretching from here, but like Chet just said already, we don't talk about future developments. So, well, you have to stay tuned to what's coming up. Why Kotlin? A couple of reasons. One of them, it's you create less boilerplate, so less verbose code, which is awesome. You have a strong type system with nullability at the language level, which allows you to make sure that you could get null, but you have that built in, and you have to make sure that you, when you return null, you're very conscious about this. Also, there's interoperability between Java and Kotlin, which is an awesome feature as well for us, because, well, old Android or classic Android development has been done with the Java programming language, so that means that a lot of developers are slowly migrating from one to the other, or still have code that is in parts of their application which is in Java. So you have to kind of have these two languages side by side for a while. And also with us, a lot of the APIs, well, Android is built, a lot of that is not written in Kotlin. So we want to make sure that there is interoperability with that. And like I just said, with coroutines, we have structured concurrency, which is also really, really cool, because this way you can easily create asynchronous code without having a lot of callbacks, which essentially just make more spaghetti code rather than actually nice callbacky code. All slides is nice and good, but let's take a look at some code. Just to answer your question, why Kotlin? Well, I really like it. It's one of the ways that has been said in the past a lot is it's a fun, concise language, which is true. Like I just said, the nullability is in a type system. So if you have the question mark in the end, that means that you could get null because, well, is it a bundle or is it null? You ask yourself that. So it's really nice to read as well. You can have lambdas, with named parameters or without them. You also have extension functions. So in that case, it is an extension function to capitalize a string, which you can also have in a template expression. So that means that you can have a string, and instead of saying plus something at the end of a string and then add another string to that, you basically just can call a function within a string declaration, and that it's being checked at compile time, which is really, really cool, and I like that feature a lot. And you can have, you also have property access syntax. So that means that for getters and setters that have a property with the same name that's back to that, or like in our platform version, in platform code with the Hungarian notation there, then you can just call fab background tint list and then access it and set it in that case using equals rather than say set background tint list and then pass the tint list in. So that maybe makes up for nicer and easier access for that, and also reads a lot nicer in the end. So why Kotlin? Another thing why we really like it is if you have a concise language that you write code in, that is less code that you write, then you get a lot more development speed. So we're working with coroutines. We said coroutines for the past years. We're looking at it. It was experimental. Now we fully support that from the Android perspective. We're looking for a flow as well and added a lot of extension methods. That's what we said, and that's what we thought about it. But let's take a look at some numbers. Developers really like Kotlin, and we can see that by more than 60% of pro Android developers use Kotlin in their applications. And more than 70% of the top 1,000 apps contain Kotlin code. So these numbers, within a couple of years that we just had it out there, actually shows that a lot of developers actually care and understand also why Kotlin is a nice language and why they should be writing the code in Kotlin. And I also remember that when we announced that at I/O that we're supporting Kotlin, there was a massive cheer in the crowd, and ever since, people were really excited to see where we're going with that. So let's take a look at the things that we're doing to improve Kotlin on Android. One of the things that we're doing is we're focusing on tooling with lint checks, with a dedicated compiler team, with just, for example, R8 optimizations, working on annotation processing speed with the simple processing that you can check out on GitHub. You can take a look at what we're doing there as well. So we're doing a lot of the development as open as we can, working closely together with JetBrains on the Kotlin Foundation that JetBrains and Google founded together. Another thing that we're doing with Kotlin is we're doing Annotation Platform APIs. That means the thing that Chet just talked about, the recently nullable, recently non-null APIs, that over platform releases will change to nullable and non-null annotation. So that means a recently annotation will give you a compile time warning, and in the next release, that might give you a compile time error. So you have time over one release that you can change that from your recently nullable ways. Like, okay, I see that there's a warning, and for the next release, you have to make sure that you pass it, that you convert your code and update your code in order to not have a compile error. So that's one of the things we're doing there on the APIs from platform side. We also create a lot of extension libraries for each of the, well, as far as they make sense, for our Jetpack libraries or stuff that is baked into the platform as well for improving the platform APIs next to the actual platform releases. So that's really cool. So let's take a look at one of the APIs that a lot of us had struggled with over the past, which is in order to create a bitmap and put that to a drawable object. Basically, you have the function to create a bitmap, and then you have the drawable API where you draw something on a canvas. And in order to do this in the first place, well, you had to do a lot of things. First, you had to get the bounds, then you had to set the bounds in a drawable, then you had to create a bitmap with your configuration, then you had to create your canvas or get it from somewhere, put the bitmap in there, and then set the bounds on that. There are a lot of things that kind of can go wrong in between that from start to finish, like putting the parameters in the right place and all that. Also, it is a lot of code. So we have a drawable KT, which is the Kotlin file for drawable, which gives you the 2-bitmap file, so essentially the 2-bitmap function. So that means you can just create a call to bitmap with the width and height and the configuration you want to give this, and you get a bitmap back. Essentially, all you have to do now is you say drawable to bitmap with the width and height, and that's it. So instead of having, well, a lot of code, you basically just have one line of code, and everything else is being encapsulated for you as developers. So that means we're trying to make your lives easier with this. And I think that's a very good success where we actually make it easier because it's easier to read, easier to write, less mistakes to make from your end. Another thing that we're doing is we're doing Kotlin-specific APIs. For example, for Room and Work Manager, we have made coroutine support to make sure that asynchronous code, writing asynchronous code is a lot easier for you. For paging 3, we rewrote it completely in Kotlin, including coroutine support from the get-go. For Compose, Jetpack Compose is our new UI toolkit that's completely written in Kotlin as well. And, well, we do have docs, samples, and training. And here we do docs, we do samples, and we do training. No, not just training. We do code labs, courses. We do articles and videos. For example, the Kotlin vocabulary series is one of the recent things that you definitely should check out on our Medium publication, as well as on the YouTube channel. There's a lot of really interesting information in there on getting started with Kotlin and how you can use it on Android. That was the first pillar that we were looking at with the language, with Kotlin. So let's take a look at the next pillar, which is Android Studio with tools. A lot of it is it's based on IntelliJ with support for writing code, refactoring, and all this capabilities that we have there. And well, let's take a short look back. I know that time is running on, so that's why I talk really quickly. I'm very sorry for that, but here we go. 2013, I remember I sat at I/O in the keynote room next to Hassan and was nudging him when Hugo Barra said, hey, Android Studio is coming on with IntelliJ, based on IntelliJ. This is really awesome. And I was very excited. And we have been excited ever since. The Constraint Layout has been introduced with tools as well in 2016. It's also where we deprecated the Eclipse Android Developer Toolkit. We added Kotlin support with CPU, memory network profilers, new system UI, for system and UI, and all these things. We added D8, which is the default compiler for Xcode in 2018. Some more profilers over the year. We added a graphical tool to create navigation throughout the year as well in late 2018 at the Android Dev Summit. And we added view binding and loads of other things with tooling support in order to make tools easier to work with. And recently, also with Android Studio 4.0, we added the motion editor with perfect support for not just 100% perfect, but getting there really good to use motion layout support. So in the meanwhile, what we're doing there is we have possibility for extremely powerful code refactoring with Android Studio, thanks to the stuff that JetBrains did with IntelliJ in the first place. We have an extensible UI for future tooling, and we have also possibility to work with JetBrains on core plugins and UI and the core and the plugins that we're developing with JetBrains, and also the community has possibility to easily add their own plugins to that as well. So, for example, the navigation editor was built on top of this, also the motion editor and motion layout, and a lot of the tooling that we nowadays see when you look into Android Studio, and not just into the code, but also into the design editors that you have in there. And we do have a tight integration with Kotlin and Gradle as the build system, which back in the classic world, well, we didn't really have that one build system. A lot of people were using Ant, some were using Eclipse's build tools, some were using Maven, and now we have Gradle as the default build system, which is really awesome as well. And we do have lint checks and several quick fixes that we roll out over the years and over time as we improve that with the dot releases, or sometimes even with the major releases if it's a major thing. And well, most importantly, we have integration with new and existing APIs. For example, with navigation, layouts that we have, data binding, room, and whatnot. Another thing, because we're kind of out of running low on time already, instead of talking about everything in Android Jetpack, because that is our opinionated APIs that are unbundled, that you can also in many cases have backported API support. So that means that you don't have to write all those checks about. You don't have to write all those checks, but we can write the checks whether this is supported on the API level. If it's not supported, then we can either stub it out or give you an implementation that works, which it might be not as powerful or the optimal implementation like the one that is built into the framework, but we still have something that does the job. So let's just talk about part of it. For these APIs, again, a timeline. We have had Constraint Layout as one of the first things coming out in 2017. We had first set of architecture components with lifecycle, view model, room. Then we had Jetpack as the brand as announced as well, with paging, navigation, and work managers supported in this first Android Jetpack release. We had material design components, which are being used in order to create and use material design on your Android device, on a new Android application. At Google I/O last year, we announced Jetpack Compose and Camera X. So let's jump into a couple of these things. Also in the motion layout, motion editor was announced as well. So, well, these are the monitoring APIs. There's lots of more, like Chet said. It's more than 70. I checked. It's 83 top-level libraries that we currently have for Android X, which is the code name, the code that you will be using for Jetpack. So you have the package, which is Android X, and Jetpack, which is the name that is kind of surrounding the code on top of that. One of the things was, well, really complicated diagram. If you look at that, is well, lifecycle. If we're taking fragments into account, it's got to be even worse. Well, even more complicated than that. If you want to make sure that you have that you get everything, every callback on every different state that your app might be in, then you would have to implement all these methods and all these functions for each of the states that we have, for on pause to on destroyers, hard resume, and so on and so forth. Well, we don't have to do that anymore, because with lifecycles, we basically have the app compat activity and the app compat fragment, which are both lifecycle owners. So they implement the lifecycle callbacks for you. And what you can do is you register a observer, and which then you're able to use that observer object and are able to for example, in that case, have the annotation for the lifecycle event on start, and then you have your function which is called start, and then you can write all your code in there. So instead of having your on start, you can write your code in there. Also, you can check whether you are in the right state of your lifecycle. So if the lifecycle, for example, in that case is started, then you're doing some code. Otherwise, you don't. Another thing is, well, we have on the one side, we have the user interface, which is consisting of, well, views, fragments, activity, and all these things. And on the end, we have the data side, which in our case, we added view model and live data. Well, view model has possibility to have multiple live data. A activity, fragment, or view can start observing each of these live data within there, and can also interact with that, which is pretty awesome, because that separates the model and the data that we have from your user interface and gives you a reactive approach. And we also bake this into Room. And with Room, you can access, you can basically send down data from the live data into Room, or into which then goes into SQLite database. One of the cool things about Room that I mentioned earlier is that you have support for coroutines built in. So that means instead of having to write your own code in order to get off the main thread, you can just use the suspend keyword, and that way it's easier for you to get off the main thread. With all these things in there, you can, instead of on top of that, on top of Room, you can also use a paging library, and that way you would get back from the live data a page list rather than getting everything at the same time, but you get a subset of the data that you have. This is really cool for massive data sets or endless data sets even, that or potentially endless data sets. that you want to update your UI on over time. So these APIs with Jetpack we have, they work together quite well, and it's definitely worth using them in unison as far as they make sense to you in your application. Not every application has to have all of them, of course, but we make sure that we enable you to integrate between one and the other. So let's take a look into all these different things for that. They're all built to work together. Like I just said, ViewModel and live data are aware of the life cycles of your application, of the activity that you have. And also, this way, we'll avoid leaks of, which were a big problem, big cause of crashes back in the classic world. This way, for example, one of the things that happened is you updated UI elements which are not active, and happened to me a lot in the past as well, where I was wondering, why doesn't this work? Why doesn't something show up properly? That was because, I was holding on to an instance of something and was still doing stuff on there. So this is really hard to do right now because, now we have, with ViewModel and live data, we make sure that we update only the right data there, the right UI there, sorry. And for example, we have the same for Room, which is also being accessed through the ViewModel and live data. So that way we also avoid leaks there. And because it has coroutine support built in, you can also do that, the updates off the main thread without having to do a lot of threading and having to care about it a lot. So all of that is encapsulated. Like I said, it separates your data from your UI, which is really cool. With Room, you can use that with coroutines and also with Flow. And it keeps your database access off the UI thread, like I just said already. And all of these architecture components are friendly for RxJava. We don't have RxJava in here in the samples, but it works, and we have support for that. Another thing that we do for tools is for the new studio templates, we make use for navigation in that case. If we create a basic application, you also get a nav graph, which consists of 2 fragments in that case, which can navigate from one to the other. And that nav graph underneath has a XML file, which looks like this, and you can basically change all your IDs and destinations that you want to go to. So basically, you have a destination for each fragment or activity that you want to address, or for each destination that you want to address, and you can address them by IDs. So that means instead of having to create a new intent to navigate somewhere, or actively using the fragment manager, what you're doing is you're just saying, with the nav controller, you're just navigating to something which has the action ID, in that case, first to second fragment. With navigation, you also have possibility to use navigation arcs, so with safe arcs that you're passing between data, between destination. That's also, we have UI. You're able to create UIs for single activities with easier fragment management. And you have a consistent up and back handling, which you have been asking in the past a lot. And it has support for on-demand dynamic features recently added as well. With this library, let's take a quick look at Work Manager. Work Manager allows you to run deferrable and guaranteed background work. And it's not a replacement for exact work like Alarm Manager, but it's a replacement for most of the code that you're writing that has to be run in the background at some point, because you don't have to make sure, if you're not writing an alarm app, then it doesn't really matter whether this runs at 6:05 or 6:10 or whatever. But it matters that everything that you wanted to be able to run, that it is there, so that you have internet connectivity, or that you have enough battery, or that it's charged enough. And these things are more important than actually when this runs. This is backwards compatible down to API level 14. We throughout those use either Alarm Manager, Broadcast Receiver, Job Scheduler, depending on which API level you're on. And we have support for periodic tasks. So that means a task that has to happen every day, for example. We have possibility to have chained and chained tasks that are either sequencing or parallel, so things that have to happen at the same time. That's great that they can happen at the same time with an API that we have there. Also, you can say the first set of tasks have to happen first, then the next set of tasks can happen, and then the next one. So you can process data then locally in parallel. Then you can, for example, compress it, and then you can upload it to a server. Also, you have the possibility to define your constraints. So, for example, if you have connection, or the device is charging, or something like that. Like I just said, you could have tasks that are in parallel. So if we take a look at this, this would be three image filters that are going on. And in this case, we want to make sure that the battery isn't low in order to make this, because this is battery intensive. So we want to make sure that there is enough battery for this to happen and it doesn't run out of battery, because that would be bad for the user. Then after that, if there's enough storage available, then we compress the data onto the device. And afterwards, in this chain, what we're doing is we're uploading the data to our server for these images. That all works in an unmetered network in that case, because that's the constraint that we set here. The API in general is fairly simple. We have the work manager, which we have the worker, which in that case is our filter worker, which extends from the worker class, and you have the function do work. And well, within the work before the result success, this is where you do all your things that you want to do. This is where you write all your code. And then result success says, this is fine, this has succeeded. Or on the other hand, if something fails, then you return the result failure. So that means that you know that this has failed and you have to handle this otherwise. Another really, really cool thing that we added is support for foreground services. So that means that your code doesn't have to be deferred anymore. That also means that you can use Work Manager to run long-running operations immediately. So something that should outlive your current lifecycle, should outlive your activity. You can run this with set foreground info, adding a notification. So your user sees that there is a small notification going on. You can run all your code and execute that. And then afterwards, the foreground service goes away again, and you get the same information back. So then you do some work again, and you return the result success. Let's take a very quick look at CameraX before we start wrapping it up. And with CameraX is a library that we introduced in order to make development of camera applications easier and the use of cameras, because we have learned that this is kind of tricky and kind of hard, so we wanted to make sure that it gets easier. It works on 94% of Android devices with API level 21 or above. It gives you consistent outputs across different devices, and it's a lot easier to use than the old way in order to create pictures. If you ever had the problems with aspect ratios, making sure that everything is oriented the right way, you know what I'm talking about with this. We have three main use cases. The first is preview. This is the way that you would just want to preview an image. And you basically want to take a preview image. You have the possibility to also do image analysis. So if you have, say, for example, an augmented reality application that you want to use that for augmented reality in that case, or if you have something for image classification, you can do that as well. And the third one is just simply capturing an image, which is a fairly widely used use case as well. So let's take a look at the easiest way to capture an image, which essentially use the image capture builder to set a target resolution, which in that case is 600 by 800 that we're setting. If that doesn't work, the system and CameraX defaults to the next available resolution that you can use. So that means that you will get a result, and as long as there's a camera available, you bind that to your lifecycle of your current camera provider, and then then you take the picture. So I know there's a lot more APIs that we could dive in depth. We don't have the time for this, and there's more than 80 of these out there, and there's just so much time today that we can talk about this. So let's continue on a higher level with this. So meanwhile, for the modern APIs, what we have is we have very frequent releases, more than yearly. So currently it's a bi-weekly release cadence for alpha libraries that then can over time propagate into betas and stable versions, or release candidates and then stable versions. New APIs can be used while they're in development. So that means that you can give us feedback, and you can also give us input on these as well while we are developing them. The most famous one that we're currently developing, or the one that we're looking at, for a lot of feedback as well, is Jetpack Compose. We also just shipped Hilt and Paging 3 as well. We have issue tracker components for each and every one of these, as well as for all the other libraries that I haven't mentioned today. And please use them. Please use the issue tracker. Make sure that you follow the feedback there, because the teams use these for the input and for the information they get out of this. And they classify and prioritize their bugs depending on this information that you give us as well. One last thing before we finally wrap up is the distribution. For distribution, we're now using the Android App Bundle, which we have announced in 2018 at Google I/O. And well, we learned that 3 in 10 phones have less than 1 GB of free internal space. So that means that users on-device storage is kind of a premium. And we also saw that with that space that is there, very premium, that users are likely to uninstall devices depending on how much uninstall applications depending on how much space they have. That means the installation success rate declines depending on APK size, and we've learned that depending on the regions that you're in, that your APK, if your application is about 3 MB smaller, it is 1% more likely to being installed. That number varies depending on the region and the device availability, as well as on the cost of data and storage and a lot of other things. So but it's a good rule of thumb with that. So what did we do to fix this? Instead of giving a user everything everything that they might not ever need, we just pick the things that the user actually might need. So the CPU architecture, if there is native code, we just give the user on their device the stuff that they need. Same for the density, as well as for the languages that they need. So we skip out a lot of things, and we do this through Android app bundles with dynamic delivery. So every user only gets what they actually ever will need. And on top of that, we made it possible for you to create even smaller applications through on-demand feature modules. So that means a user is able to get parts of the application and might not ever have other parts that they might not be using. So, for example, somebody has doesn't go for the checkout process of the application, so they don't actually get the module for your checkout. You can also uninstall modules. So, for example, you have an onboarding flow that might take up a lot of space, so you can uninstall that later on as well. Some numbers on the current adoption of the app bundles. We now have more than 500,000 applications in production using app bundles, and they're amounting to more than 35% of the active installations that we're seeing. And nearly 50% of the top apps and games are using app bundles to distribute their applications. And we've seen about 20% of download savings versus a monolithic application, versus a monolithic APK with that. So taking it all the way back, we have modern Android development under the roof. We have, for the language that we're using as a pillar, is Kotlin. The pillar and tools is Android Studio with all the stuff that we have in there. With APIs, we have all the architecture components with Constraint Layout, Motion Layout, Camera X, Material Design, Navigation, Work Manager, and all these things. And for distribution, we're counting on the Android app bundle as the main distribution mechanism. If you want to learn more about this, stick around for the Q&A, as well as go on this site for modern Android development, so dandroid.com/modern-android-development. And with that, thank you very much.
Again, we have to thank you. Well done. Great talk. Also, thank you for all of the new informations and everything I haven't heard in person yet before. So I think we're going to do the same thing as before. I'll just go through the questions we have. This time I'm even able to unmark them, and I'll start with some which came in actually through chat's talk, but are also related to right now. Do you recommend using Hilt on production projects because it's still on alpha?
Okay, I'll take this one. I think it's really up to the developer. It's actually up to you. So if you think that the library as it is right now fits your use case, I don't see why not. So right now, Hilt is actually built on top of an internal library that we are using in production for a long time already. So again, if it fits your use case, then go for it. And that's it.
Sounds great. Thanks. Is there a way to enforce compile time failures only for recently not null, recently null warning without affecting all other compiler warnings?
You can add your own lint check to that and make sure that that fails. Yeah. So essentially, just add a lint check and make sure that fails rather than a warning.
Nice. Then a bit more of a technical question. Are the sample apps written by the people who wrote the corresponding platform or library code? If not, do the API authors perform a code review on the samples?
Yes, no, sometimes. So the samples are sometimes written by the folks that write the APIs. In many cases, they're written by folks in developer relations. The reviews are usually being done through peer reviews, as much of the stuff that we're doing is peer reviewed through, in that case, the wider team as well as the developers of the APIs.
Nice. Very concise answer. Thanks. Sorry.
Yeah, it said that if you find something weird, feel free to file a bug to the GitHub link.
Yeah, we have recently changed a lot on the structure that our samples are being done. So that means one of the really cool things that recently came out is that we now can accept contributions directly from GitHub. I know that in the past that was a major concern, a major issue. So that means now if you actually create a pull request on a GitHub repository and that gets merged, that means that we can have that internally as well. And we also shift a lot of the development of our samples to the open. So as soon as they're released, we still have per repository, depending on that, depending on the repository, but we do have different ways of communicating there. But every sample category has a clear owner, and everybody can contribute to these samples.
I love that. Thank you. The next question is about Camera X. Why does it only work on 94% of the API 21 plus devices? What are the 6% missing?
Here, if I don't say mistakes, so first, it's because, API 21 being Lollipop is currently at 94.1%, I would say, and it keeps growing. It's just we're relying on some system APIs that can't be brought back, if I don't say mistake, to KitKat. That's why.
Which work manager version added the foreground service feature, and is it limited by some min SDK version?
I provided the link to which one exactly, to 4.0 beta 01.
Perfect. Thanks. Two more, unless there are some which I don't see right now. With AAB becoming mandatory in the future, will developers be forced to upload their signing key to Google?
Well, there's multiple ways on this. So what we can do is we can create a signing key for the developers as well. And also, the way that Android app bundles work is the signing key has to be there in order for us to create the APKs that then can be shipped to the user. Two things that we've been hearing a lot is the concern of security on this. So we're using the same security for the key that the developer uploads that we are using for our own keys, for the keys that are within Google. And the second thing that is there is one of the really cool things for developers is if a developer uploads the key, which gives us the possibility to create APKs in the future as well, means that if there's optimizations in the tooling, then we can recompile that bundle that you have uploaded and give a newer version to your users. So if we, for example, have something back in the days, we introduced Zoftly as the new algorithm for compressing the APKs, which allowed us to do, for example, Delta updates. So that means that in that case, we also can apply that to new downloads of your application. So there's a lot of benefits to this.
I wanted to point out, Wojtek posted an article on Medium with a lot of information about app signing, and I was going to share what it looks like to make that a little easier. If you can see that. Answers to common questions about app signing by Google Play. So.
Nice. So yeah, we see the link. Can you just post them onto our chat?
Yes, I will do that. I'll stop presenting now. All right.
Thank you. And then we have one last question, at least in this chat, is like, who is in charge of maintaining the Google OSS licenses plugin?
We have a Google OSS licenses plugin.
Don't shoot the messenger.
We might have more than one of these. There might be more people involved in this.
I think, if I don't say mistake, it's the plugin where you can actually pull the license from all the dependencies you're using to be able to show them in one of the view. I don't know.
If there's an issue with that, we'd like to learn more about it. Very happy to also follow up on this. Just shoot me a message on Twitter or find me on GitHub or wherever, and I'm very happy to take a look at that and forward that to the right people, or help you find the right ID for the issue tracker, a component for the issue tracker.
Nice. So then we have one last question from Etienne, who asked, like, yeah, it's a bit late, but it's not too late. It's fine. I've been keeping an eye on the evolution of the shared flow Kotlin proposal with a link. I'm just curious if you have any extra context to share on this, if it's something your team tracks and so on.
Yeah, I can chip in here. So we are not working with them on the actual proposal, but some of our people in our team reviews the PRs. So for example, Boyard reviewed the Stateflow PR. And now we are working closely with them with the shared flow and how that fits into the use cases for Android in particular. So for example, I'm talking with him about how we could integrate the live, the single event problem that we have to work around in Android currently with live data to see if there is actually an easy way to include it in shared flow. Short answer so far is no, but we are keeping working with them and see how we can improve it. And after that, like shared flow right now is in PR review, but then like we will see how we could integrate these new experimental APIs into our guide to app architecture.
Nice. It sounds like a great answer to me. Same thing Etienne says. With that, I think it's Yassine, it's your talk. It's your time, sorry. Your time for your talk.
All right, let me share my screen. And we should be good. Here we go. Yes, perfect. All right. So, hello everyone. Welcome to my talk on adapting your apps for Android 11 privacy changes. So for the ones who don't know me, my name is Yassine Rezghi, and I'm a developer advocate at Google on the Android team. So let's go on privacy changes. Privacy changes, it's really important for us. Smartphones, as well as tablets, are becoming such important device for user, and they're holding a lot of their personal and private data. So on Android, privacy is an area where we've been evolving a lot over the last several releases, and we will be continuing to do that a lot on Android 11. So Android 10, for the ones who were familiar with, we brought a lot of changes in that direction to evolve our platform for even more protection for users' data, as well as control for them. And today we will be talking about the enhancement in Android 11. So on Android 10, we brought scope storage, permission changes, foreground service types, and now we'll be bringing more on that. So first, let's talk about one-time permission. So what we checked with our users is whenever they're given a choice, users always prefer to share less private data with their applications. And we also saw that many apps request background location access with no need for it. So based on users' feedback, as well as developers, in Android 11, we're bringing users more granular control over users' private sensors. So location, camera, microphone, and significantly, limiting access to background location. We'll deep dive more into that. So users will be able to grant temporary one-time permission for location permission request. As you can see in this small screenshot, they will be able to choose that. That will be transparent for developers if they're following the best practices. That goes same here for microphone access. You can imagine an app, for example, where you have a user who can call the support of an app. And usually it's quite rare you will actually call your support within an app specifically for that app. So rather than granting all the time, you may just be granting during the call itself. So whenever you only select only this time, in this case, the application will have access to microphone, camera, or location only for the time where that application has a foreground service or a screen being the main screen. So if they're quitting that, or if they're putting that on pause in background, they won't be able to have access to those anymore. Same thing for camera. Let's imagine they may ask you to show you your house for fixing a specific thing there. Rather than, again, here showing all the time, giving them access all the time to your camera, you can give that for the only session where the app is up. And maybe you may have this important question in mind as a developer. Do I need to change anything in my code with one-time permission? Which is usually what your product manager or your own developers will ask you if you have to do that change. And actually, you don't have to do anything if you're following the permission best practices. So let's go and check those permission best practices. You get an idea of what you should do if you're not doing it already. So let's imagine this simple app where the user can tap on the location button to request location. So here, the first thing we'll do, as you can see on the code, we'll check if that permission is granted. And after that, we will ask the system to decide if we have to show a rationale or not, to be able to give more context to make sure that the user understands why they're giving access or not. And based on that, we may see that rationale, or we will just having the request permission. Keep in mind, specifically from Android 10, we may show a notification to the user that sometimes we tell them this application have been using recently your location or microphone or camera. So even though we're bringing in this one-time permission, from Android 10, we saw a lot of developers, a lot of users were actually disabling access, were removing the access for one of those permissions by checking the settings. While before it was always possible, now because there is more transparency on which apps using which permission, users will do that more often. So you should never assume you have a permission all the time, because that may be removed by the user. And in the case where we don't need a rationale, we'll just request the location, and it would prompt that dialog to the user. Now let's take the case where the user may press deny, for example. In that case, we'll have the onRequest permission result callback that will be invoked. And the permission, in this case, is rejected. So we should make sure to explain which functionality won't work because of that decision. Here, it's a lot of context. We need to tell the user why we need that. If we just ask straight from the app startup, like we saw in some application, we saw most of the cases, users will deny them. So in this case, we'll show an explanation to say, for example, in this snack bar to indicate why this functionality is not available and that we need the permission for that. And to give user fine-grained control, in Android 10, we split the permission between foreground and background location access. So applications were encouraged to incrementally request this permission to give user better control. So first, foreground, and then all the time location access. In Android 11, this pattern has become a requirement. So here again, rather than asking straight background location access, you may first to get it for foreground, and after that say, oh, we may give you notification when you're nearby your favorite restaurant to give you more context about it. And in that case, you should give us background location access, rather than from the beginning asking all the time. And anyway, in Android 11, we're removing this opportunity. So there is no change on Android 11 for foreground access request, and it will be adequate for most use cases. Again, here, you should not ask the most verbose permission from the beginning. You should ask what you need, and after that, maybe expand that permission if the context is required. And for background access, when you're targeting Android R, there are two changes. It's good practice to incrementally request permission to give user a chance to understand and decide based on context, as I mentioned. So instead of asking for foreground and background together, you should only ask for background location after your app has been given foreground access. And this pattern is recommended on Android 10 and has become, again, a requirement on Android 11. And when your app requests background location permission, the request permission API will send user directly to the settings instead of the regular permission request dialog. So here, it's rather than them just maybe clicking yes, yes, because they might not understand the context here, they will be sent to the settings, so it will give them maybe more time to understand what they're giving to their favorite applications. And it's good practice to educate the user before requesting the extra permission. Again, here's always give context to users before asking them, because most of the time they might refuse it. Make sure to provide also the option for the user to refuse, since there is a rate limit. So basically, if you ask more than 2 times and both times you have been denied, we will be able to ask you, we'll ask you, sorry, to go straight to the settings to be able to change that by themselves without being able to do that through a dialogue. So again, here, do not just request straight with no reason. Yeah, so this is the screenshot and the user experience given to them. And to ensure compatibility for application targeting Android 11, so API level 29, if I don't say mistake, it is allowed to request both foreground and background location permission at the same time. And you will have the extended dialog shown instead. So that's only if you're targeting Android, API 29, which is Android 10. But again, I feel because here we will be moving to the next target SDK probably next year, you should just make sure that you're following the right behavior from the beginning. It's even better for the user, and you will have to do less migration at that point. So that was for one-time permission, and now we'll go for data access auditing. So for the person who asked me the question before, you will have the answer now. Let's talk about a new API we're bringing here for developers to understand which part of that code is actually calling for private APIs. Private API asking for private sensors. So users might be frustrated, and you may have seen that in some comments on the Play Store or somewhere else. Hey, I don't understand why this app is asking me for my location. I don't understand why they're asking me for my camera or for another permission again. Here, maybe because of a lack of context, and maybe because you may have been using part of your dependency, a third-party SDK, or maybe just even your old code that you completely forgot that it made that call. So here, what we're bringing with this new API, you will be able to figure out precisely where that call came from. So how would that work? Basically, again, sorry, I'm just going through my slides quickly. You will be able to tag part of your code to say this part is accessing this location service manager, or this part of the code is accessing this other API. With this new API, you will have a callback on data access, and you will be able to feature tag. So imagine you may have like a logging feature on your application. You may send that maybe to Firebase. You will be able to see precisely which part of your code is asking for that. And in this case, it presents with all of these lines of code currently you may have where big application may have thousands of lines of code, if it's not even millions of lines of code, where it's really, really hard to figure out, again, where they may access location, contacts, or microphone. Here, we're bringing you the right API for that. So let's have a look on how the API actually looks like. So we'll be able to ask here, get system service, and we'll be asking with the apps ops manager, we'll give a callback where we will get all the details about the API that have been called. And that will goes for synchronous access. So when you're actually asking for the microphone, when you're actually asking for contacts or location, but also for asynchronous access. So if you're listening to a broadcast, or if you're getting a listener on something that doesn't go straight when you're actually calling your code, you will get any notification directly there. And here you will be able to distinct directly on your app level or more at your activity level and putting a tag for each part. So let's see how it goes in terms of code. We will create an attribution context. So it's basically just a context here, but it will be tagged with the string we're giving here as a parameter. And whenever we get one of the system service that we actually need, we'll call from that context. So whenever we ask for one of those service, like location, as I mentioned, or contacts, it will be tagged. So in our system, we will be able to see find friends actually ask for that piece of information. And also in your callback, you can just get the stack trace and just see in your logs which part of your actual code called that. And if you don't know, maybe it might just be one of your dependencies, and you might be able to update or remove that dependencies if it's a problem for you. So that's all the data access here, giving you to understand which parts of your code is calling any of those private sensors APIs. Now, let's move on to foreground service types, the new one we're bringing with Android 11. So for the one where we're on Android 10, we already brought some of them. So we had like the sync, media player, phone call, companion device, media projection, and locations. So big thing there for us is to bring control and transparency to user. If you were using any of those service types, the user will constantly see a notification that can't be removed, because we think it's important for them to be aware that one of their private sensors API, or one of the important API, is being used at the moment. And with Android 11, we're bringing more on that. So on Android 10, only the media projection and location were actually enforced to ensure for accountability and access. But now we're bringing more. So we're bringing the camera as well as the microphone, and you can declare both of them. So when you target the API level, because maybe you may have a hard time migrating because you may have other priorities, but I highly recommend you to target Android R there. And in this case, you will be able to declare camera and microphone as new foreground service types. Again, here, the user will be able to see that active notification all the time. They can stop it, but while it's still there, you will always be able to access any of those specific APIs. So to recap, the foreground service that are actually, you need to declare them. If you're not declaring them when targeting API R, so the next Android version, you won't be able to access nor the camera, nor the microphone and location, which was already the case on Android 10. So that's for the new service, new foreground service types. Moving on now to package visibility. So on Android 10 and older, whenever you call this API from Package Manager, get installed package, you will be able as a developer to get access to all the application installed on the device. And there were no restrictions there. But as I mentioned earlier, privacy is really important for users, and as well as for them to be able to restrict access to some APIs, as we've seen earlier. It's also to bring more accountability. So make sure that developers actually declare and just say, oh, I need to have access to I need to check that this application exists because I have a great integration with it, for example. But let's see some of the integration we're bringing there. If you're querying any of the system applications, so the one that you will have by default with Android, you will not need to make any change. But for others, the change are actually super minimal. So whenever you need to query and get the results from that API, again, you don't need to change that much. If you target Android 11, so it's, again, protected by Target SDK, but I highly recommend you to upgrade your Target SDK. When you will request your own application, you won't have any change. It still works as before, no problem. But if you get installed packages by default, you will have only the app and system packages, not the new one, not the other applications. But the good thing is, if you actually need to, if you're showing an implicit intent, so if you just do start activity with an intent like share content or action get content or action view, there is no change there. You just need to bring, you just need to target the API level and you will have no problem with that. But if you want to have Sorry, same thing there works for content provider. If you're actually declaring that you're using one content provider, you will have no problem with that too. But if you're asking a specific other app, by default, you will have an exception. Even though that application may be installed, we won't tell you directly if you didn't declare properly in your manifest that you need to check for that application. We'll just tell you this app doesn't exist. But let's imagine you have one of the use cases where I mentioned you may be from the example company in this case, and you need to check that the other application made by your company, which in this case may be store or service, are there to enhance the experience, for example. You will have to declare them in this query tag inside your Android manifest file. So you just put the package name there, and whenever you will access the API that we see earlier, so get package info with the package name, you will have an actual result, if it exists or not. And if you want to send an intent like action send, and you want to tie it specifically for images, you will have to declare that intent and the actual filter you want to apply to it. So in this case, it's specifically to the JPG MIME type, but you can put a star on image/star, or you can even be more wide and put just star and get all the MIME types. But again, here, for accountability, make sure you're just declaring what you actually need rather than just being broad. And we have, for specific use cases, a new permission named query all packages. So if for a specific reason you want to check all the packages without having to declare them all, because we know how diverse is the Play Store ecosystem, you will have to put this permission. But so you know, because we think normal applications should not be able to access all applications installed, this will certainly trigger a review by the Play Store team. So here, if you don't have a proper use case, I highly advise you to not do it, because you may not be able to get it. So that was on the package visibility, but we also thought maybe rather than having to create your custom share sheet and having to declare the intent, maybe you just want a better native experience. And for example, when you're checking for Google News and you're sending an intent, so a link, the user click on that, and they will just want to be able to see the news on Google News, you will have this share sheet. I mean, can we just call it native dialog here? It may be better. You will have this native dialog where you will have Google News as well as Chrome. But in the case where you may actually don't want to give them Chrome, you may prefer a native experience, we're bringing a new flag available on Android 11. Flag activity require non-browser. And in this case, when you have the application that is actually native and can handle that link or this intent, we will show you the right native dialog. But if you don't have it, if the user didn't install Google News, we will just raise an exception, activity not found exception. Like that, you can say, I have this great experience, but it's not available until you install the app, or maybe you just launched the intent without this specific flag. So now you can control that without even having to change your manifest and adding the query field that I showed earlier. So yeah, if no native apps are displayed, you will have this exception and you can handle it in your UI. If you need to play with this package filtering and test your application to make sure there is no issue on your migration to the target SDK, you can play with ADB. There we have the right API for that, and it will be able to show you all the right logs in Logcat. Now on to scope storage. I know I have 8 minutes left, so I will have to go a bit quicker. So scope storage has been introduced in Android 10, and the idea here is we want to bring separate storage into collections to limit broad access. Applications shouldn't ask for all the storage by default. They should just ask for what they actually need, like we saw earlier. And also better attribution. So like that, we make sure whenever you create a file, maybe it might be a photo, a video, or an audio file, we know it's attached to you, so we can show that in the settings, rather than your app still being the same size as it was installed, it will include also all those files that you created. And also it should protect app data. So now no application won't be able to access your external storage by default on Android 11. So that's better protection. And to protect user data, again, to just not give a broad access by default. So on scope storage on Android 10, we also brought those collections. So as an application, you can create, so you can add media files as well as any type of file onto the download folder without even having to ask the permission. And you will be always having access to those without having to request the permission. So here, rather than getting refusal from the user, you will just be able to get access to those simply and the same API as before. And it's enforced by Target SDK. So if you had really issues with that, we always had the request legacy external storage to help you ease the transition there. So on Android 11, after all the feedback we got on Android 10, we brought some changes because we're more comfortable now with scope storage. And one of the way is we're renaming storage to files and media, so it's more clear in terms of permission to the user. And with the Target SDK R, write external storage and write media storage do not grant any additional write access anymore. So that's the thing to know. You can just stop with the Max SDK with the permission in your manifest file. And also with Media Store API, we got as a feedback that deleting or editing a lot of files at the same time may not be the best way for users to show constantly a new dialog. So here you can create bulk edits, which is represented in this way to users. Also, you can designate some media as favorite. So you can flag them as favorite, and in the default gallery, you will have a favorite collection that the user can check and consult and edit, share, etc. You can also put your media into a trash collection. So there is, by default, your files are still staying on the user's device for 30 days, and after that, it will be removed. So you won't have to remove directly, and it can give some bandwidth for the users to make sure that they don't need it back. So in terms of how it looks like, this is the media store create request. I may just have to go a bit more quickly because I don't have that much of time left. But as you can see, it's a simple API where you can just give the URI that you actually want to modify to the content resolver, and you will get the whole result back on activity result. And that's the UI you will get. Obviously, after that, you can check if you got it granted or not. So we're bringing also some file access restrictions. So you can't have the action open document tree on the root, on download folder, and Android inside data or up. It's because those folders are considered kind of sensitive. Download, you may have a lot of sensitive information there. We found that users are just not comfortable giving access there, so we're restricting that access. But you can still ask for a specific document inside download. So if they need a specific folder or document, they will still be able to do that, just not at the root level. But we're still restricting any access into Android/data or Android/ob, as those folders are sensitive for applications. The other cool thing that we're bringing with Android 11 with scope storage is a direct file path access. So here what we're doing, we used Fuse for the one where it's just a virtual file system that you can create on many systems. But behind is just Media Store. So if people thought that it's actually a different API, it's just using Media Store API behind, but we abstract it. So like that, you can still use the same file API as before, but it may have a performance impact, as we have to go through every folder to get all the details, all the children, to be able to return that to you. So be aware that it's handy to use, but it still has a performance impact. So it's not a different API, it's just proxy on top of Media Store. So for best performance, always use Media Store's API. But if you need that direct path access, because maybe you may be using a native library that needs file API, you can still do that. We're also bringing a special app access. So an app access that we found with the storage access framework sometimes may not be easy to just ask every time one file at a time. even with action open document tree, there is some edge cases where it might be hard to use the API. With special app access, you can have access to all the external storage that I mentioned earlier, so no sensitive folders, but to the one that you may be used to through the storage access framework. And we call this new permission in the actual manifest file manage external storage. But in this case, we don't want to grant it to anyone. It's not a case just for file manager and backup and restore. It can be if your application has a specific use case, but it has to be reviewed by the Google Play Store team. And when you will have to ask the user, it will actually show the settings. So you have to send an intent to ask for access. It won't be like the common permission. That's why we call it a special app access. So now I'm just going quickly over some other important changes that are definitely good for users. So before 111, the read phone state permission covers a broad set of information. So you had the call state, where you might check if the phone is actually ringing, idle, as well as phone numbers. We're separating that. So now you will have the read phone state, which is actually only the phone state, while read phone numbers is the new permission specifically to get the actual user's phone number. And we think it's better to separate in that case because not everyone should get the user phone number. And as the fine-grained permission protected by the target SDK, you will have to change your manifest file to address those changes with the target SDK. Also bringing some MAC address restrictions. So non-system apps, so not the default one that interact directly with the system of Android, won't have access to the MAC address. Here is to protect against fingerprinting. We think applications should not have access for that use case. So you won't be able to have access to all of those. The details are there, but you can definitely check our Android 11 changes page to get more information if you're affected with those. And we're restricting also the developer access to the system alert window. So if the user didn't properly give access to that, you won't be able to have access by default. The preloaded apps are still granted by default, but you can ask the user to give you access. You just won't have it by default. So that's for me. Thank you very much. If you have any question, well, I'll try to answer now, but if you have after that, just feel free to ping me on Twitter. Sorry, I'm 49 seconds over my time.
I think it's barely acceptable this one time. No, thank you. Thank you so much for this talk. Also, I'm chiming in with the chat there, just applauding you. Thanks so much.
Thank you.
Okay. Again, I'm looking through the questions. If you have more, feel free to add them. Right now, I see 4, and I'm just going to start with the first one. If the app goes into background for an interruption like a call, will the app lose immediately the permission for the one-time permission?
Good question. To be honest, I didn't test that part directly. It's an opportunity for me to double check that, but I doubt but I need to make sure. So whoever asks me that, just pick me again after, like that I can confirm it.
I read that question during Yassine's talk, and I gave it a bit of thought. So I don't think that it will lose that, because what happens is the app goes in background and comes back. So that means that your activity is paused, is stopped, and then is being resumed and all that. So even if your activity is recreated, this is fine. So the permission that you grant is for the lifetime of the application that you're running in now. So if the app is killed, then yes, you will have to re-request. But if the app is still running, which in the case of a phone call is the case, it would be fine. You wouldn't have to re-request.
Oh yeah, sorry, my bad. I misunderstood it. So what you have to consider, it's a foreground service, so it's not only the foreground view. So your service is still there, the notification is still visible, so the service won't die. Maybe the foreground UI may be paused, but you still have the foreground service.
Let's iterate over the question again, because it was my one. I have an application which shows map the location of the user. He just goes to the notification, selects one message, uses Duo or WhatsApp and comes back, and while that, the application is also killed. Or even if it's not killed, because in the end, you open completely different application at that moment.
Yeah, that's fine, because you have the foreground service notification going.
Okay.
Here we're talking, there's a difference between the UI and the service. But again, if there isn't like more details to check on that, feel free to just ping me on Twitter and we can like, take that offline.
Okay, thanks.
Cool. Then I can just jump to the next one.
Yeah.
Are you not afraid we'll see a lot more foreground services being used when only this time depends on the app being in the foreground?
Well, me personally, I'm not afraid, because if you have a lot of active notification, you may just have to think twice. Hey, am I giving access to my camera to 15 applications at the same time? That's obviously first like a problem for your battery as well as the performance of your phone, but it will just give more transparency. Here, the goal is giving transparency to user. After that, if they want to close an app, it's up to them, but at least they're aware of what's happening at the moment.
Great. Do you have to add queries entry to the manifest if all you want to do is use a share intent, but not display your own app picker?
Yeah, as I mentioned, if you're just using the system dialog, native dialog, so the own picker, you don't need to change anything there. So if you're just using start activity, the transition is transparent for you. It works straight away.
Nice, thanks. And the last one on this list is for specific app package checking, there was a famous code snippet to check if any Chrome is installed, production dev stage, etc. So this won't work as well.
Well, here again, the goal is not to restrict that, because there is actual good use cases to be able to access to a specific application. It's just you have to declare it. So if you're targeting, and I again highly recommend you to target the next SDK, you just have to put the Chrome package ID inside your queries field. So it's just being transparent.
Great answer there too. I'm out of questions right now, which doesn't mean that there aren't any more. So if you have a question, just feel free to put it in the chat right now.
I also can stop the recording, so you can ask the question if you are a bit shy to ask the question during the recording.
Cool, then let's all wave in the camera for 1 second. Hassan stops the recording, and then we can ask private questions. Thank you, this was great.